Hi, this is Jason Molesky. In this example, we'll explore a discrete random variable. A baby's Apgar score is the sum of the ratings on each of 5 scales, which gives a whole number value from 0 to 10. These Apgar scores are still used today to evaluate the health of newborns. So let's say we wanted to know what Apgar scores are typical. Well, to find out, researchers recorded the scores of over 2 million newborn babies in a single year. Now imagine selecting one of those newborns at random. Let's define the random variable x to be the Apgar score of a randomly selected baby 1 minute after birth. The table here gives the probability distribution for x. So you can see the values range from 0 up to 10, and we have the corresponding value or corresponding probability of each of those values of x. First, let's show that the probability distribution for x is legitimate. Well, in order to be legitimate, we have to show that all probabilities are between 0 and 1, and they add up to 1. Well, notice every one of these probabilities is indeed a number between 0 and 1, and if you add them all up, you will get a total of 1. So this is a legitimate probability distribution. Next, let's make a histogram of this probability distribution and describe what we see. Well, to make a histogram of the probability distribution, we'll make bars for each particular value of x, and the height of the bars will be equal to the probability of that value occurring. In this histogram, we can see the shape is skewed to the left and single-peaked. So a randomly selected newborn will most likely have an Apgar score a little bit higher on the end of the scale. For the center of this probability distribution, we can see that the median value is 8. And for the spread, Apgar scores vary anywhere from 0 to 10, but most of the newborns are somewhere between about 4 and 10. Now, suppose doctors decided that an Apgar score of 7 or higher indicates a healthy baby. What's the probability that a randomly selected baby is healthy? Well, to find the probability of choosing a healthy baby, we have to find the probability of x being greater than or equal to 7. We can calculate this probability by adding up the individual probabilities of x equals 7, plus the probability x equals 8, probability x equals 9, and probability x equals 10. Adding those values up, we get a total of 0.908. So we'd have about a 91% chance of randomly choosing a healthy baby based on this information. For some additional practice with discrete random variables, try exercise 5.